not xi, but x. X is your observation. We're not counting, we're not going to do yours and your classmates. No, just yours. Your observation. Okay? Doesn't have to be a grade, but it's the observation you're testing. Generally, when we're talking about tests, we're testing our score. But maybe you're talking about melting metals. Yeah? And you're looking at the melting point of aluminum. Not xi, just x. Okay, so x minus x bar is the average over s. S is the standard deviation. Now, in this situation, you got a 95. The mean, I've already said, is 80. And we know the standard deviation, again, remember the standard deviation is 10. So your z-score would be 1.5. Okay? 1.5. 1.5. Now remember, what the z-score tells us is how many standard deviations away from the mean you are. Okay? There are two components to a z-score. First, the sign. This tells us direction. Okay? 1.5 in the positive direction. Now, imagine you are right here. You're at 1.5 standard deviations away from the mean. Okay? And we're going to use z-scores a lot in chapters 5, 6, and 7. Okay? Now, just to get the hang of it, let's try it again. Except let's try 60. I don't have that drawn in our picture, but I did. You should know 60 is how many standard deviations in your head. Think about 60. Standard deviation is 10, 80, 60. Okay, just to confirm on the formula, 60 minus 80 is minus 20. Minus 20 divided by 10 equals minus 2. Okay? Minus 2. Well, it's not actually negative 2, but it's 2 in the negative direction. Okay? Or 2 to the left. And you're going to see that here, again, on our picture exactly would be 60. And this is the z-score. Okay? And this is how it works. Okay? Very simple. Just tells us where our observation is relative to the mean. Something I didn't talk about very much in the beginning of this class, in Chapter 2, was scatter plots. Scatter plots are a very powerful graphing tool, and something we're going to use to graph bivariate data, both numerical. Now, height and weight. We talked about this just a little bit earlier in the lecture. Height and weight, I talked about in grade school. I was taller than most of the kids, so therefore I was heavier than most of the kids in grade school. This is because there's a strong correlation between height and weight. Okay? And so as my height increases, and it doesn't really matter if we're measuring in inches or centimeters or what, and I'm just going to plot, as height increases, generally the weight increases. And so on the y-axis, weight increases by going up. On the x-axis, height increases by going over. And we can see this kind of linear trend. We can see a linear upward trend between height and weight. Now, we measure height and weight with the coefficient of correlation. Okay? Scatter plots are always measured by the coefficient of correlation, and we denote that R. Okay? R. Coefficient of correlation. Don't ask me why. R, it just is. Okay? And so R is a measure of two things. It's a measure of strength, and it's a measure of direction. Okay? Here, we're pretty tightly correlated, so it's going to be pretty strong, and it's in the upward direction, so it's positive, and I'm going to say 0.8. Now, if you want to look at your book on page 129, there are a lot of these relationships, and they go through it pretty good. So I just want you to pay attention in your book. I'm just going to quickly go through one other observation. Okay, so this is positive correlation. Now, negative correlation is something like positive is when one variable goes up, the other variable goes up. But negative correlation. As one variable decreases, the other variable increases. And think about something like birth year and age. Now, as your birth year decreases, your age increases. Think about it. If you were born in 80, 79, 78, your birth year is decreasing, but your age is increasing. Yes? And so let's look at this. And so as your birth year decreases, if this graph starts at 1900 and it goes up to 2000, I'm assuming we don't have anybody who was born after the year 2000. Okay? So, at 1900, you are very, very old. I don't know any better way to say that. If you were born in 1900, you are very, very old. Okay? If, as your birth year increases, your age decreases. Yes? Or conversely, as your birth year decreases, your age increases. As your age increases, your birth year decreases. Okay, so it works back and forth. But what we have is a negative correlation, and this is very, very strong. So negative, your R is going to be negative, and it's going to be very, very strong. 0.99. Now it's not going to be 1. It's not going to be a negative 1. Why is it not going to be negative 1? If I told you I was born in 1975, would you be able to tell me how old I am today? Would you bet your house on it? Are you 100% sure you know the answer? No. Why? Because it could be before my birthday or after my birthday already when you're watching this video. And so there are two options for age on any given birth year. Yes? You might have been born in 70. Where does that put you? I'm not sure. I can't exactly tell you your age, but I can get pretty close. I can get within 1, but I can't tell you exactly. So it's not going to be a 1. Okay? But coefficient of correlation, or what we call R, or I'll just shorten it to correlation. Okay? Correlation vary between negative 1 and 1, and 0 representing no correlation. 0 representing no correlation can look like two things. It can look like a horizontal line, or it can look like a shotgun pattern with no clear linear pattern in it whatsoever. And you can see those in your book. Okay? Now, quickly, I want to give your homework. Okay? I want to give your homework. And now, I will write these down. So, your homework this week is number 3.3 and 3.4. Okay? I assigned 3.4 so you can check your data in the back of the book. It's okay. 3.21. 3.24. Always the even should be in the back of the book. 3.29. 3.42. It has to do with college basketball. I was a college basketball coach. I was a professional basketball coach, so this one is of good value to me. 3.43. It has to do with college football and trying out for the NFL. And since I know Texas is crazy about football, I included this one. And 3.61 and 3.68. Now, I don't want you to do a case this week. I don't want you to do a case this week as we prepare for the exam. Okay? And I'm going to back the exam up to next week because I want you to totally finish this, grasp it, do the homework, get it graded, evaluate it, and we'll do the test next week. Okay? Thank you.